Most trigonometry story problems go through the process, draw a triangle, label the triangle, write the equation, solve the equation. But the tricky parts might be, do you understand what the vocab is saying? And also, do you actually see a right triangle? Now, not all trig problems are like this, because we do have that S equals R theta formula for arc length, and they'll also have some problems where they just give you the formula and you have to solve them. But for the most part, they're set up like this. And so in this problem, we want to find the height of a tree T if we're standing 50 feet from the tree, and it gives us an angle of elevation as 60 degrees. Now, the reason we often give an angle of elevation of 60 degrees is because we know short leg times the square root of 3 is the long leg, and so we don't actually even have to write the equation. We know 50 times the square root of 3 is the height of the tree. Now, I can show you how to do that with a formula as well, but keep in mind to look out for those 30, 60, 90 triangles. And if you were actually measuring the height of a tree and you had a clinometer, you might want to stand at a distance from the tree so that you could see the top of the tree at a 60-degree angle. That would allow you not to have to write an equation, but just take the short leg times the square root of 3. The other thing you'll have to do is decide, is this a draw a triangle and label the triangle and write the equation problem? So if I have a problem, let's say I have a 10-inch pendulum, if I try to make this problem into a triangle, I just cut my 10 inches in half, and that's kind of weird. And I don't even have a radius anymore, and let's say I wanted to find the angle theta, and I knew that the pendulum swung in t equals 1 second. So, like 1 second, 2 seconds, 3 seconds, 4 seconds, and all of a sudden the seconds are running all along the arc, and I might realize, hey, I'm tackling this wrong. This isn't the draw the triangle problem. This is an S equals R theta problem. And they would need to give you a little bit more information, like how far it traveled in a second. And so let's say the T is equal to, the arc length, the length of the black line, is equal to 21 inches. So if this is traveling 21 inches in 1 second, then I might realize, well, this whole thing is 10, so I really don't have a side of a triangle at all. And if I use the S equals R theta formula, I'm actually finding this angle. And if the question is asking for the small red angle, I'm going to have to use S equals R theta and then divide it out. So this might be arc length 21 equals radius 10 times theta. I divide that on a calculator, I get 1.05. And then if you don't think very well in that type of measurement radians, you could always multiply by 180, divide it by pi, and get theta equals about 60 degrees. But then if you're going to give the red angle, let's just like thinking about your picture, the red angle is a smaller one, so the red angle would be about 30 degrees. So here's a problem involving a boat. You know that bearings are the measurement clockwise from north, and so if it gives you a bearing of 30 degrees, it's telling you that this angle is 30. And if the boat is starting here at a bearing of 30 and it's traveled 10 miles, that's right there. And then it asks how far east has it moved from its starting point. It always helps me to write out north, south, and we for west and east. And so I'm just asking how far is that horizontal length. And if I have a 30-degree triangle, I should know the second verse of the SOHCAHTOA song, short leg, multiply it by 2 is the hypotenuse, and then you're done. X is equal to 5. But for some reason, if you didn't know that, here are the steps. Draw the triangle, check, got it done. Label the triangle. 10 is the hypotenuse, x is the opposite side. Write the equation. Sine of 30 equals x over 10. Solve the equation. If you're going to type this into your calculator, you type it in as 10 times sine of 30. Make sure your calculator is in degree mode, and it will give you 5. Some problems are going to be more mathy and have you find things like the angles in a rhombus. And so you have to know what a rhombus is from geometry. All the sides are the same length. So I'm going to draw a shape that has all of my sides the same length. And the sides are all 10. And it has one diagonal that's 16. So obviously from the way this is drawn, it's the longer one that's going to probably be 16. So this is 16. And I want to find out what the angles are. Well, I have to take a really close look at this to figure out that answer. Let's see. Do you see a right triangle when you look at this? Like when I look at this, I can cut this in half, know that this is 8 and this is 8, and if I wanted to find this angle x, I look at my 8 and my 10. The 8 is the adjacent side, the 10 is the hypotenuse, and I can write an equation, cosine of x equals 8 over 10. If you're finding the angle, you have to use the inverse button. So at that point, you just get out your calculator and make sure that if you want your answer in degrees, you have your calculator in degree mode. And if you want your answer in radians, you have your calculator in radian mode. I'm going to go for degrees and type in inverse cosine of 8 divided by 10. And I find out that little angle x is 36.86 degrees. And if that's that angle, I can use it to get all the rest of the angles because these two are congruent because it's a rhombus. And this one up here, y, adds to 90 with x and fill in everything else. And then because this is pre-calculus, you'll have some problems that might be just flat out harder, and you'll have to be able to do triangles within triangles to get to them. So let's say we have angle DIC is 60 degrees because we have an equilateral triangle. And the sides of the equilateral triangle are 36. So 36, 36, 36. If we were to take and cut a 45-degree angle down here, what would the length of x be? So x is just this section. So let's look at what we know because of our 30, 60, 90 triangle. First of all, I got to look at the right triangle. So I've got to look here. And we've got short leg times the square root of 3. So this is 18 square root of 3. Short leg times the square root of 3 is the long leg. But now I have the whole long leg is 18 square root of 3. What if I wanted to just get x? Well, I couldn't use the 60-degree angle right here. I would have to use the 45-degree angle in the smaller triangle. And so in the 45-degree triangle, x is just 18 because it's isosceles, so those two sides are the same length. And if I wanted to then go up and find this length, y, I would be 18 square root of 3 minus 18. You'll have some problems like these in a separate worksheet. You just need to work them out as they come to you. You will have a quiz on exact values before we start the homework assignment on story problems, and the next video will be over new things, graphing sinusoidal and cosine functions, and make sure you listen to that one. Have a good evening.